A function rule is an equation that determines the value of the output of a function f of x, given the value of the input x. In other words, a function rule tells you what's happening inside the function machine to go from the input x to the output f of x. Up until now, when you've been evaluating and solving, I've given you the function rule. For example, I said w of x equals 3x minus 6. However, you are also able to write your own function rule. In fact, you know a lot about writing a particular type of function rule, a linear function rule. A linear function rule is a function rule of the form f of x equals mx plus b, where it's always okay to write f of x equals b plus mx instead. A linear function rule describes what happens inside a linear function machine. When an input x is put into a linear function machine, that input is multiplied by m, that constant rate of change, and then we add b, the start value. This produces the output f of x. This should sound really familiar because it's really familiar. This is exactly like writing a linear equation in slope-intercept form, writing an equation y equals mx plus b. The only difference here is that we're using function notation. So instead of writing y equals, we're writing f of x equals. That makes it really clear that our output is a function of our input. Everything else that we know about writing linear equations, though, it still applies. Let's go ahead and practice that. First example is of a linear situation. Pranathi has 65 pieces of gum. She chews 5 pieces of gum each day. Just like when writing linear equations, we are starting by defining our variables. So what does x stand for? What does y, which in this case we're calling f of x, what does f of x stand for? We're describing in words what the variables are. In words, the x variable here stands for time, as it often does, where time is measured in days. F of x, what the situation is describing, is how much gum Pranathi has left. Just like for linear equations, we're defining our variables in words, no numbers involved. Only difference is instead of defining y, we're defining our output f of x. Now when we write our function rule, this is just like writing a linear equation, identifying the start value and the rate of change. Here, the start value is 65. Pranathi starts with 65 pieces of gum. The rate of change is negative. It's -5 because she chews gum. The amount of gum she has left goes down each day. In our linear unit, we would have written y equals 65 minus 5x, or y equals -5x plus 65. Either one of those is fine. Either one of those is fine here, except instead of writing y equals, we're writing f of x equals. For a situation, I like to write f of x equals 65 minus 5x, but f of x equals -5x plus 65 is also okay. What this function notation makes really clear is that my gum, f of x, is a function of my input x time. So the time determines how much gum is left. In fact, I can find how much gum is left by multiplying that input x by -5 and adding 65. Next example, another linear situation. Drew has 53 pet penguins. He adopts 1 new penguin each year. Start value, constant rate of change. This is a linear situation. When I'm defining my variables, once again, x represents time, but this time is measured in years. The situation is talking about what? What does f of x stand for? F of x stands for how many penguins Drew has. I'm just going to write number of penguins. F of x is just fancy for y. What does y stand for? In our linear unit, we would have written y equals 53 plus 1x, or y equals 53 plus x, or y equals 1x plus 53, or y equals x plus 53. Any of those are okay, but I'm going to use f of x instead of y so that I'm making it really clear. How many penguins Drew has is a function of how many years have passed. So f of x, I'm going to go ahead and go start value plus invisible 1x. To find how many penguins Drew has, I add 53 to the number of years. Those are situations from which I wrote linear function rules. I can also write a linear function rule from a linear graph or table. Let's start with the table. I know that this table is linear because it exhibits a constant rate of change. My output, my savings, is going up by 100. That's my f of x, or my y, while x is going up by 5. That means my rate of change is constant. My rate of change, my delta y over delta x, in this case, delta f of x over x, is 100 over 5, which is 20. This is a linear table. That means I can write a linear function rule. My variables have already been defined for me. X is time, measured in years. F of x, my output, is savings measured in dollars. Now I'm not going to forget everything I know about linear tables. Just like in my linear unit, I'm going to write my start value and my rate of change, and I'm going to use that to write my equation. Just now I'm going to write f of x. So I can write f of x equals start value 100 plus 20x, or f of x equals 20x plus 100. Either of those is fine. I just want to remember not to write plus 100x. I need to use my rate of change, 100 divided by 5, which is 20. Last example, which is a great one to practice as often as possible. It's super important that you can write an equation and therefore a function rule from a linear graph. We know this graph can be represented by a linear function rule because it's a straight line. We need to find the y-intercept, which gives us the start value, and then to draw a slope triangle to find the slope. Since points aren't given, I need to draw my own on the grid. That gives me a lot of different possible slope triangles. I'm going to go ahead and do this one. Rise of -2. Run of 1, 2, 3, 4, 5, 6. That tells me my slope is a rise of -2 over a run of 6, which simplifies to a slope of -1/3. When x goes up by 1, y goes down by 1/3. When x goes up by 1, y goes down by 1/3. I am now able to write my function rule. In our linear unit, we wrote an equation. We wrote y equals mx, -1/3 x, plus b, plus 2. When I'm writing a function rule to describe this graph, everything I already know about linear graphs applies. I just write f of x equals, instead, f of x equals -1/3 x plus 2.